All right, we're at 5.3, double angle, power reducing, and half angle formulas. Just like we said in 5.2, you do get a formula sheet, so don't worry about memorizing these, but the important thing is to know how to use them. You'll notice the top of my formulas right here. This is from yesterday, or 5.2, sum and difference formulas. So there you just see them written out, so they're ready to use. Okay, we used those yesterday. Always can come back to them if it'll help us change something, but that's where we're at on that one. Okay, and then so today we're adding 2 or 3 different other kinds. We have the double angle formula. So if we have an angle, we double it, we have different choices. I will warn you, this double angle formula for sine of 2 theta, that one is one you may want to memorize. You will see that very, very frequently, and it'll come up a lot in calculus. So that is one that is beneficial to just memorize. And it's nice and easy. Sine of 2 theta equals 2 times the sine of theta cosine theta. It never changes. It's there. You'll notice on the cosine of the double angle, you have 3 to choose from. You can either use cosine squared theta minus sine squared theta. You can use 2 cosine theta, 2 cosine squared theta minus 1, or 1 minus 2 cosine squared theta. So that's a variation, and really what you want to do when you choose that is say, do I want to cosine and sine? Do I only want to work in cosine? Do I only want to work on sine? That's kind of one way to choose which one you prefer on that one. And then you have your tangent of a double angle as well. Power reducing does exactly what it says. What if you're given a sine squared or a cosine squared or tangent squared, but you don't want to work in those? And what this formulas do is it reduces the power and allows you to work in just the thetas or something, or cosine, sines, or thetas. Actually, if you notice, it goes to cosine on every one of them, and it gets rid of that power. Half angle formulas is what we're thinking. So it takes half of the angle, it takes an angle you know, and it allows you to work with half of that angle, which might not be on the unit circle, and that one. You'll notice sine and cosine have an exact half angle formula, and tangent has 3 you can choose from. You get to choose whichever one you want. Super, super important to realize that when you're doing those, which one do you want to work in? Do you really want to work in a radical? Probably not, so you're probably going to choose one of the last 2, okay? One thing I do want to point out to you right here is the plus or minus in front of it. In the case of this one, you choose the plus or minus that goes with the values you're working with, okay? So it's super important to realize what you're working with as we work with those half angles, okay? And I should have made sure I knew what I was saying clearly before I do this. We'll get there. Okay, I'll get there when I get there. I need to clear my thoughts as I do this. Okay, so let's look at example A down here, the first one. It says use the figure to find the exact value of cosine of 2 alpha. Okay, notice on this one, my alpha is coming from this triangle they already drew me. I have a 7 and a 24. Does anybody remember what the hypotenuse has to be? It is, it's 25. A 7, 24, 25 triangle. If you didn't remember that, use Pythagorean theorem and solve for that angle. Okay. So we are using the cosine of a double angle. So if we look up there at the top, that's the one we can choose 3 of, okay? Because we have nothing else to work with here, I am going to just go ahead for my 2 alpha here. I'm going to choose the first one, which is cosine squared alpha minus sine squared alpha. Okay, just to kind of give you a feel for where we're getting these values and stuff. You could choose either of the other 2, and our final answer should be the same. Obviously, the work will look different, but the final answer should be the same. All right, alpha is this angle I'm looking at. So the first one wants me to find the cosine of this angle. So if you remember, cosine is adjacent over hypotenuse. So the cosine of alpha is going to be the adjacent, which is 24, over the hypotenuse, which is 25. So in for alpha here, I'm going to plug in 24 over 25. The cosine, and I need to square it. My sine of alpha, same exact angle, is opposite over hypotenuse, so I'm going to have a 7 over my 25, sorry. And I'm going to plug that in for sine, 7 over 25, and I'm going to square it. So now comes the fun math. What is 24 squared? 576, but don't forget we square 25 as well. 25 squared is 625. 7 squared is 49, and thankfully 25 squared is again 625. We do have common denominators, so we can go ahead and subtract. 576 minus 49 is going to give me 527 over 625, and that is going to be the value of my cosine of the double angle of 2 alpha, okay? If we would have chosen one of the other values, we would have had, if you think about it, we would have had a little bit more fraction work and common denominators and such, but we would come up to the same value of 527 over 625. All right, moving on to the next page. All right, find the exact value of 2 theta when the cotangent of theta equals 2 and theta lies in quadrant 3. All right, definitely need a picture to help me with this. Okay, we're in quadrant 3. Remember, when you draw triangles, you always use the x-axis. You drop it down from the x-axis. Your theta is always closest to the origin. Cotangent. Cotangent is, tangent is opposite over adjacent, so this is going to be adjacent over opposite. It equals 2, and there's nothing on the bottom, so that puts a 1. So that means my adjacent side is 2, my opposite side is 1, and I need to do a little Pythagorean theorem to solve for my hypotenuse. All right, so a squared, b squared, c squared. I'm looking for my c. I have a 1 squared, I have a 2 squared. That's a 1 plus a 4 equals c squared. So c is going to equal, lack of space there, I'm just going to go ahead and shortcut to square root of 5. Okay, so I am finding sine of 2 theta. So if you look at sine of 2 theta, the formula says we're going to do 2 times the sine of theta cosine theta. Okay, so 2 times sine of theta here. Sine is opposite over hypotenuse, so my opposite is 1 over my hypotenuse, which is radical 5. My cosine is adjacent over hypotenuse, which adjacent is 2. My hypotenuse is radical 5. All right, put this 2 over 1. Across the top, 2 times 1 times 2 is 4. Across the bottom, 1 times radical 5 is 5. And I get a value of 4/5 for my cosine of, or sine of my double angle is 4/5. All right, for C, I'm verifying my identity. Again, I need to choose which side. 1 minus tangent squared on the left and cosine 2x and cosine squared x on the right. Big idea over here. I have a double angle. I have a squared on the right. I've got a mess over there to get it all to squared on the right. I think I'm going to, or on the left. I think I'm going to work on the right and go from there. My cosine of 2x, I have 3 choices, okay? So if you think about this cosine of 2x, I can do cosine squared x minus sine squared x. I could do 2 cosine squared x minus 1. I could do 1 minus 2 sine squared x. Okay, those are my 3 choices. And whichever one I choose is going to be over cosine squared x. And I need to make sure that I get a tangent. Okay? So if I'm over cosine squared x, I really want sine over cosine. So I don't want the middle one because I'll never get that sine in there to get that tangent to show up. All right. So the question is, do I want cosine squared x minus sine squared x on top or 1 minus 2 sine squared x on top? If I do 1 minus 2 sine squared x, I'm going to get 1 over cosine squared, which is secant squared, and I don't have that on the left, so I might not want that. I think my best choice is the first one. Okay, so for cosine 2x, I'm going to do cosine squared x minus sine squared x all over cosine squared x. I have 2 terms on top, 1 on the bottom. On my left side, I have 2 terms, so it'd be nice to separate them into 2 different terms. So I'm going to get cosine squared x over cosine squared x minus sine squared x over cosine squared x. My cosine squared x's cancel. I'm left with 1. And sine squared over cosine squared is the same as tangent squared. And my right side now matches my left side. So I've verified my identity. And I'm going to be honest, you could have chosen one of those other 2. It might have just taken you multiple steps to get it in so that it matched the left side. So if you can kind of visualize ahead where you're going, it might save you time in your verifying. Otherwise, you just might have a few more steps, which is okay. All right? All right. Using a half angle formula to find the exact value of tangent 75. Now, I want to kind of refer you back a little bit to the sum and difference ones. Yesterday, we did something with 75, and we did the sum where we added 45. No, we didn't. We did 105, I guess, yesterday, where we added like 45 and 60. For 75, I'm just trying to do quick math here and see if I can even think of what I want to do. If you could do it other ways, you could do 30 and 45, right? But if I ask you on a test or quiz to do half angle, I want to see the half angle formula. Even though a sum would get you the same answer, I want to see the half angle if I ask for a half angle. So just keep that in mind as you're working through these, okay? All right, so here we go. I want to find the exact value of 75, and I want to use the half angle. So if you think of 75 degrees, right? 75 is half of what angle, okay? So if you multiply by 2, you're going to get 150, okay? So we actually want to use 150 as our theta, okay? So we're doing a tangent, my half angle formula, okay? And if you look at your half angle formulas, you can choose a lot of different ones. I'm going to be honest, I would never choose the left side if I could avoid it. The one with the radical, I wouldn't use it. So the question is, do we want to have something different on the bottom, 2 terms on the bottom, or 2 terms on the top? It really doesn't matter. You want to go 2 terms on the top? I can do that. 1 minus cosine alpha, or in this case theta, right, over sine of. Okay. So because we chose, we're doing the half angle, we know our theta is 150. So tangent of 150 over 2 is going to be 1 minus. Okay, this is my, my theta, 150. I don't plug 75 into the right side at all. I don't plug 75 in anything. I just know that 150 over 2 equals 75. I use 150 on everything. So I'm going to do the cosine of 150 degrees, and I'm going to do the sine of 150 degrees. Okay, so I'm not using 75 in my math because I'm using this half angle formula, which is able to take an angle that's on my unit circle and use it. Okay, so let's think about 150. 150 is in my second quadrant, and it has the ordered pair of negative radical 3 over 2 and 1/2. Okay, so coming over here for work, 1 minus the cosine is my x value, which is negative radical 3 over 2. All over my sine, which is my y value, which is 1/2. All right, across the top, a minus and negative is a plus. I need a common denominator of 2. Okay, so I'm going to multiply both top and bottom here by 2. So I'm going to get 2 plus radical 3 all over 2 on the top, all over 1/2. I want to clean this up as much as possible, so I'm going to keep change flip. So I have 2 plus radical 3 over 2 times 2 over 1. That's flip. 2's cancel. And it looks like my final answer is 2 plus the square root of 3. Okay. There are more than one way to get that. Okay. We could have used the other formulas. We would have got to the same place. Okay. But keep that in mind as we do that. That you get to choose what probably will be easier math. If we would have chosen the right one, we would have had to use a little conjugate work to get our radicals out of our denominator. So keep that in mind when you make that choice. All right, are we ready for a power reducing? This one's a doozy. Okay. Use the power reducing formula to rewrite 6 times sine to the 4th power x as an equivalent expression that does not contain powers of trigonometric functions greater than 1. That means when I get done, I want all my sines, cosine, tangent, whatever I have, to only be to the 1st power. So it's okay if they're a double angle or anything like that, but we don't want any powers, okay? So our goal really, when you stop and think about this, is we don't want a 4th power. We want everything to the 1st power. All right, so we're going to leave the 6 out front. It doesn't have anything. My power reducing formula, and by the way, sine to the 4th, let's think of that as sine squared x times sine squared x, okay? Because that's what sine to the 4th is, would be the 2 there, okay? So if you look at the power reducing for sine, it says we're going to take that sine squared x and we're going to make it 1 minus cosine of 2x. It doubles the angle, okay, all divided by 2. And we're going to do it twice since we have 2 of the sine squared x. So 1 minus cosine 2x all over 2. Okay? We really have a binomial times a binomial here, so we're going to go ahead and FOIL it. I'm going to give you a hint, though. 2 times 2 is 4. If we bring it out with the 6/4, we don't have to worry about that. And I'm just taking 1 minus cosine 2x times 1 minus cosine 2x. Okay? And that's easier than trying to multiply fractions in there. Okay, so we're foiling. First times first is 1 minus, if you can handle this, cosine 2x times, the outside is 1 minus cosine 2x, the inside, I'm sorry, is negative cosine 2x, the inside's negative cosine 2x, so I get 2 of the cosine 2x is negative. Outside times outside, or last times last is going to be a positive cosine squared 2x. Okay. And don't forget 6/4, or I'm going to reduce it to 3/2 is out front, okay? All right. I have one issue here. I still have a power, okay? So I'm going to leave my 3/2 out front. I'm going to leave 1 stays the same, 2 cosine 2x stays the same, and I'm going to power reduce that cosine of 2x, okay? So cosine squared of 2x, if I use the power reducing on that one, says that I get 1 plus cosine, and this is super important to realize. When you look at that power reducing, it doubles the angle. This angle was 2x. We're going to double that to 4x all over 2. Okay? All right, just so you can kind of see this, I have a 3/2. I have 1 minus 2 cosine 2x. I'm going to separate this into 2 terms of 1/2 plus 1/2 cosine 2x. Nope, sorry. Yes, cosine 4x. Okay. 1 and 1/2 can join to make 3/2 minus 2 cosine 2x. That's a double angle. I'm good on that one. And I have 1/2 cosine 4x, which is a double angle, it looks like. But there's no powers bigger than 1, so I'm good to go. The last thing I'm going to do is just distribute my 3/2 in here. So I'm going to get 9/4. My 2's cancel, so I get minus 3 cosine 2x. And 3/2 times 1/2 will make a 3/4 cosine 4x. And there's my final answer. Okay? Not pretty, but at least we reduced those powers out so we could do something else with it. Okay? All right, last one here. And I will tell you, we rarely use the power reducing, but it's nice to have that in our toolbox if we need to. It says, use the figure to find the exact value of 2 times the sine of the half angle times the cosine of the half angle. Okay, we already have our triangle. It's all filled out for us. We know the 3, 4, 5 triangle. And if I go to my formulas for the half angle of sine, I get it equals the square root of 1 minus the cosine of alpha all over 2. And the cosine half angle formula is the square root of 1 plus the cosine of alpha, or theta in this case, all over 2. Okay, so notice both of them, even sine and cosine, use cosine. Okay, so if I come over here to my triangle, the cosine of theta is adjacent over hypotenuse, so it's 4 over 5. So both of them are going to use that 4 over 5. So 2's out front. We're going to leave it out front. Over here, it's super important to realize this radical goes over the whole thing. So I get 1 minus 4/5 all over 2. And over here, I'm going to get the square root, again, over everything, 1 plus 4/5 all over 2. Okay. I'm out of room. Okay, 1 is going to be the same as 5/5, right? So 5/5 minus 4/5 is 1/5 over 2, all under this square root. 1/5 divided by 2 is the same as 1/5 times 1 over half, which is the square root of 1 is 1 over 10, right? I might leave it like this for a minute here. And the second one here, if this is 5/5, I get 5/5. That's going to give me square root of 9/5 over 2. All right. If I want, I can go straight across and get 2 times, are you ready? 1 times 9 is 9. 5 times 5 is 25. 2 times 2 is 4. Well, lucky for me, everything is a perfect square, so I get square root of 9 is 3, square root of 25 is 5, square root of 4 is 2. My 2's will cancel, and I'm left with 3/5. Okay? Your math won't always do that, but we will work on practicing some of those as our math doesn't do that. Okay? All right. Practicing it. And I will tell you, there are a few examples I'm going to need to bring to your awareness before we take the quiz or test, especially using the half angles with some of the pluses and minuses. I don't have an example, though, in the notes today, but hold me accountable. Make sure I show you some in journals and homework or something like that, because it is important to be able to figure out when you use pluses and when you use minuses, okay? I will try to make sure I have at least one of those journal questions on a video so you could see that if you don't make it to class that day. All right, if you want to practice, I ran out of room here, page 614 to 615, number 3 through 66 by 3s. Okay, there's a good start, but definitely bring questions and anything you're not sure of to class. Good luck.